Hello there and welcome back to Bhanzu classes. I hope you are doing wonderful and I also hope you remember what we have learnt in the last class. So let's quickly recall like and unlike fractions. So what are like fractions? The fractions with the same denominator, and it's very easy to compare like fractions. Suppose we have the fractions like 1/4, 2/4 and 3/4. So because we have the same denominators here, we just need to compare the numerators. Out of 4 here, 3 parts are colored. Here 2 parts are colored out of 4, and in this one only 1 part is colored out of 4. So obviously this one is the smallest, whereas 3/4 is the largest. So it's very easy to compare the like fractions. Now moving on, we have also studied about the unlike fractions, the fractions with the different denominators. And by the end of the last session, I also asked you to think wisely about this question. How to compare the unlike fractions? So here the fraction is 2/5 because 2 parts are colored out of 5, and in the next one the fraction is 3/4 because 3 parts are colored out of 4. Now how do we compare the unlike fractions? It's tricky, isn't it? We can't just compare them directly because their denominators are different. So what's the solution? We need to make their denominators the same, right? And then we can compare. But how do we do that? For that, we have to learn about the magical tool called equivalent fractions. So let's master the concept of equivalent fractions today. Equivalent fractions are our key to unlock the mystery of comparing any kind of fractions, adding fractions, subtracting fractions. So by the end of today's lesson, you are going to master this concept. So let's get started. Now let's go back to Jake and Sia. They have got something for us today. Let's take a look. There is a slice of cheese that Jake wants to divide between him and Sia. So tell me how much each one of them will get? You already know the answer to it, right? Yes. So each one of them will get 1 slices out of 2. Because the slice has been divided into 2 equal parts. Therefore, each slice of cheese here represents 1/2. Now, instead of 2 slices, imagine cutting the cheese or slice into 4 equal parts. Each one will get 2 parts because of equal division. What is the fraction each one of them will get now? They are going to get 2 out of 4 each, yes? Because now the cheese or slice has been cut into 4 equal portions and both are getting 2 each. But seems like still they are eating the same portion. So does that mean 1/2 and 2/4, these two fractions are the same? To see this in another way, let's cut the cheese slice into 6 equal parts now. And if you pick 3 of those slices each, they come together to form 3/6. Again, it seems like they are still eating the same slice of pizza. Whether it is 1/2, it is 2/4 or it is 3/6, they are still eating the same portion. So does that mean 1/2, 2/4 and 3/6 equal fractions? Sia says yes, these are equal fractions. What do you think? Does these 3 fractions 1/2, 2/4 and 3/6 represents the same value? Now for that, we have to do some observation. Here, I wonders how 1/2 has become 2/4. If you observe, here 1 and 2, both the numerator and the denominator is multiplied by the same number 2. And in the other part, the numerator and the denominator both is multiplied by 3. So maybe that's the reason they are so similar fractions. So if you observe, this one part has been cut into two more parts further. That's the reason we are multiplying this by 2 each. And in this one, this part is multiplied by 3. Equal divisions more we are doing. So that's why we are multiplying by 3 each. That is the reason we are getting the similar fractions. Now how about in this case of pizza? So tell me, what is the fraction of the pizza that Sia is going to eat here? It's 2/4. And what is the fraction of pizza that Sia is going to eat here in the second case? Here, 4 slices out of 8. Okay, they're still the same, isn't it? They still represent half of the pizza. That means all of these 3 fractions are the same. Because everything in math has a special name, so what do we call such fractions that represents the same value, like here in this case? Those, my dear, are called equivalent fractions. And equivalent fractions have different numerators and denominators, but they are still equal because they represent the same value. Their value is the same despite of having numerators and denominators different. Now, how to find equivalent fractions? Let's take a look. In order to find equivalent fraction, you just need to do a simple thing. Multiply, or you can divide as well, the numerator and the denominator by the same number. Do not multiply or divide the different numbers in the numerator and denominator. For example, let's take 2/6. You can multiply the numerator and denominator both by 10. You will get 20/60. So 2/6 and 20/60 are the equivalent fractions. You can multiply it by 2/2. You're going to get 2/12. You can multiply it by 3/3. You will get 6/18. That is also an equivalent fraction. Or you can divide it as well. You can divide it by, let's say, 2/2. You will get 1/3, which is again an equivalent fraction. So over here, 2/6, 4/12, 20/60, 6/18, 1/3. These all are equivalent fractions. And if you wish to multiply it by 100/100, then you will get 200/600. So that is also an equivalent fraction. So basically, if you multiply the same number in the numerator and denominator of the fraction, the result that you're going to get will be equivalent of that fraction. Now, if you observe in this bunch of equivalent fractions, you cannot divide 1/3 more further. You can divide 6 and 18 by 6. You can divide 20/60 by 20 in the numerator and denominator. You will still get 1/3. You can divide 4/12 by 4 each. You will get 1/3. You can divide 2/6 by 2. You will get 1/3. So in every way, you can come to 1/3. But from 1/3, you cannot go more down, right? So therefore, this, my dear, over here is the simplest form of fraction. So such numbers which cannot be divided more further. For example, here in 9/10, by which number you're going to divide in the numerator and the denominator in order to get a fraction? 9 comes in the table of 3, but 10 doesn't come in the table of 3. 10 comes in the table of 2, but 9 doesn't come in the table of 2. So there is no such number which you can divide 9 and 10 by and get an equivalent fraction to that. So therefore, 9/10 is the simplest form of fraction over here. Now that you know about equivalent fractions and simplest form of fractions, let me ask you a question that I've asked you in the beginning of this lesson. And the question was, can you compare the unlike fractions? So quickly apply all that you have learned and find out which fraction is greater. Okay, by looking at it, you can tell that, ma'am, 2/5 is lesser than 3/4. But what if you don't have these image representation? You have to just compare using the fraction. How are you going to compare that? So for that, let's take a look. Here we have 5 and 4. Can we make their denominators same? We can. 4 and 5 both have a common number in their table, and that is 20. So if you multiply the numerator and denominator both by 4, you are going to get an equivalent fraction, which is 8/20, right? So 2/5 and 8/20 are equivalent fractions. And if you're going to multiply 3/4 by 5 in the numerator and 5 in the denominator, you're going to get 15/20. So therefore, 3/4 and 15/20 is again equivalent fraction, right? Now we can compare their equivalent fractions because they have the same denominator. So if you compare 8/20 and 15/20, then obviously 15/20 is greater, right? That means your fraction 3/4 is greater than the fraction 2/5. And that's how we compare any unlike fraction. Now, let's practice a few more questions to master this concept. The question over here is, find the equivalent fractions of 3/4. So the fraction over here is 3/4, right? You can multiply it by any number in the numerator and denominator and can find so many equivalent fractions. You can multiply it by 2 by 2. You will get 6/8. You can multiply it by 3 by 3. You will get 9 by 12. So basically here 3/4, 6/8, 9 by 12, 30 by 40, 300 by 400. All of these are equivalent fractions and they are never ending. You can multiply it by big numbers in the numerator and denominator. You can multiply it by small numbers. So therefore, there are so many equivalent fractions of one fraction. Now here's another question. We have to find the equivalent fraction of 515 whose numerator is 35. We have to find the equivalent fraction of 515. Now we already know that there are so many equivalent fractions that exist of a single fraction. But we only have to find that one whose numerator is 35. And we just have to find the denominator over here. Now first we are going to observe that how this number 5 in the numerator has become 35 in the numerator. Clearly it is multiplied by 7, right? And whenever we find the equivalent fraction, we just not multiply the numerator with a number. We also multiply the same number in the denominator. So when we do 15 times 7, we are going to get 105. And with that, we are going to get equivalent fraction of 515 with the numerator 35. And this is the answer. Now it's time to summarize whatever we have learned today. So we have learnt about the equivalent fraction, that you can multiply or divide the same number in the numerator denominator and we'll get the equivalent fraction. And simplest form of fraction are those fractions, but simplest fractions are those fractions which can only be multiplied further to get equivalent fraction. You cannot divide them more further, that is, you cannot reduce them more further. And now it's time for you to spark your curiosity and figure out some of the equivalent fractions around yourself. Not just equivalent fraction, but fractions in your day-to-day life. I'm gonna see you in the next session with some more examples of real life. See you, bye-bye.